Good morning, dear students. My name is Ferhan Mazher, and today the subject we are studying is Cambridge O Levels Physics 5054. Today we have set our heart to solve a paper 4. We call this alternative to practical. We also called it ATP, and today we have selected May-June 2022 for one paper. And let's start this paper. The total marks for this paper are 30 and 1 hour is allowed to complete this paper. So let's start this paper. So here we go. The Cambridge O Level Physics 5054 4-1 paper. 1 hour is allowed. Alternative to practical. Okay. So the first question coming up on your screen. A student investigates how the temperature of a volume of water changes as hotter water is added to it. 160 cubic centimeter of water at 20 degrees centigrade is poured into a glass measuring cylinder. Figures 1.1, the figure 1.1 shows the measuring cylinder. So this is the measuring cylinder, and the measuring cylinder contains 160 centimeter cube of water. On the figure 1.1, draw the level of the water showing the meniscus. It's a 2 marks question. Okay. So we have to draw a meniscus here. So let me increase the size so you can see it more clearly. So here we go. You see, this is 150, this is 175, this is 200. So, so this is a difference of 25, which is represented with the 10 small units. So small divisions, I mean. So each two divisions represents 5. So this will be 155 and this will be 160. So 160 is here. The meniscus of the water is like this. It's curved, and this portion will be lower. The portion on the sides will be higher. The lower portion on should be on the 160. So let me show you. I have done this. So I will. So this is how you will show your meniscus. So this lower portion of the meniscus is in the middle, and it is at the mark of 160. So this is how you will show this. So I hope you understand this. Okay, so we are going to the next question. Let me show you the marking scheme. The marking scheme is showing up. So here we go. Okay, so the next question coming up on screen. The student pours 100 centimeter cube of water from the measuring cylinder into a large beaker. He then uses a kettle to provide a constant supply of hot water. Add 50 cubic centimeter of hot water at 70 degrees centigrade to the beaker. Stirs the mixture, records the new temperature of the water in the beaker, continues to add 50 cubic centimeter of hot water at a time, recording the new temperature for each addition until a total of 300 centimeter cube of hot water has been added. So the student ensures that the temperature of the water added each time is 70 degrees centigrade. Suggest how this is done. So what you will do from the kettle, you have the hot water in the kettle. So what he can do that he can pour the water into a measuring cylinder, and in that measuring cylinder he will measure the water. He will pour the 50 centimeter cube of water, hot water, and then by with the help of the thermometer he will measure what is the temperature, and then he will wait that the temperature cools down to 70 degrees centigrade. When the thermometer shows that the temperature of the water is 70 degrees centigrade, he will pour the water from that measuring cylinder into the beaker which has the water. So this is the strategy: is to pour hot water each time 50 centimeter cube from kettle into a measuring cylinder by using a thermometer. Check temperature of water. Wait until it cools to 70 degrees centigrade. Then pour this into larger beaker in which you have the other water. Hopefully you understand. This is the answer of the B first part. Okay, so now we are going to next question. He says, the student repeats the experiment and obtains the three sets of results as shown in the table 1.1. So this is the table 1.1. The total volume of the hot water added, that's the V in cubic centimeters. And this is the temperature, and he notes the temperature 3 times. Then he takes the average. So calculate the average time, T average, theta average, when the total volume of the hot water added is 150. So when the temperature, when the added water is 150 cubic centimeter, these are the temperatures he has measured 3 times. Then you can find the average. How you will find the average? You will add them up. 47 plus 49 plus 46 equals to, and you divide it with you divide the sum with the 3. So you will get the average temperature. So this is how you do it. So the answer will be 47.3. 47.33 is the answer. 47 in the table. Okay. So we will write here 47 because the other numbers are in two significant figures. So we will also write 47. Next question is on the figure 1.2. Sorry. On the figure 1.2, plot a graph of theta average, temperature in degree centigrade on the y-axis against the volume in centimeter cube on the x-axis. Start both the axes from the origin. Draw a smooth curve of the best fit. Okay. So your volume changes from 0 to 300, and the volume will be on the x-axis, and the temperature will be on the y-axis. The temperature is going, the maximum value of the temperature here is 54. So let me show you that graph paper. So, okay, so here, because the volume goes up to 300, so I will write here 50, 100, 150, 200, 250, 300. So this will be the volume. So I write a volume in centimeter cubes on the x-axis. The temperature is on the y-axis, and the temperature goes up to 60. So it will be 10, 20, 30, 40, 50, and 60. So this is how you will, and here you will write that here I'm representing the temperature, which is in the centimeter cube. Okay, so I can show you the graph I have. So here you can see I have written here volume in centimeter cubes, 50, 100, 150, 200, 250, 300. On this, temperature is represented on the y-axis, and you can see 10, 20, 30, 40, 50, 60. Then I will plot those points. The points are, what are the points? The points are at 0, 20. At 0, you have 20, okay. Then at 50, you have 33. At 50, you have 33. Put this dot. At 141, at 141, at 100, put this dot of 41. And then at 150, it is, I think, how much was that? 47. At 150, 47, put a dot of 47. At 200, you have 51. At 200, we will have 51, put a dot here. And at 250, you have 53. At 250, you have 53, put this dot. And then we have at 300, we have 54. So at 300, we have 54. So we'll put the dot. Then once I have done this, I have plotted the points. Then I will draw a smooth curve. So you can see here, we have drawn a smooth curve. So we have joined these points with the smooth curve. So this is what they are asking you to do. Okay, so then they say, okay, this is a 4 marks question. Then we are done with this. He says your graph shows that the theta temperature is not directly proportional to V. Describe how your graph shows this and suggest why theta is not directly proportional to V. So you see, Basically, this graph is between the volume added and the rise in the temperature. So this graph is not a graph of directly proportional because this is not a straight line graph. Its gradient is not constant. It's a curve. It's not a straight line, and it's not passing from the origin. The if the graph between two quantities who are directly proportional to each other, and the shape of the graph is a straight line and which passes through the origin. This is the curve and it's not passing from the origin. So these two quantities, they are not directly proportional to each other. So let me show you the answer. He says, I've written the answer. Graph is not passing from origin and its gradient is not constant. As the temperature of the water rises, heat lost to the surrounding increases. So why is this? As the temperature rises, you see the water in that beaker becomes hotter and hotter. The rate of loss of the heat to the surrounding, that increases. The more the temperature difference between the surrounding and the water, the loss of the heat from the water to the surrounding, that will increase. So that's why the increase in the temperature is not uniform for each 50 centimeter cube water added. Okay, so the student, let me show you the marking scheme also. Okay, so we are done with this. Okay, so that was the marking scheme. The student repeats the experiment with a layer of insulation around the beaker. On your graph figure 1.2, sketch a line to show the results with the layer of insulation around the beaker. Label this line with the letter A. Okay, so what you have to do, we have another beaker. This time, what we are doing is we are doing the same experiment, but this time we have put insulation around the beaker. So when you put insulation around the beaker, loss of heat to the surrounding, that reduces. So the rise of the temperature will be faster. So I will draw this graph. And I forgot to label it. You have to write here A. You have to write here A. Okay. So okay, now. Okay, so we are done with this question number 1. Okay, now we're going to next question. The next question is, he says, a student investigates the resistance of two resistors. Figure 2.1 shows the apparatus used to find the current I in the resistor X and the potential difference V across it. Draw a circuit diagram for the arrangement shown in the figure. Okay, so we have to draw a circuit diagram for the arrangement shown. So in this arrangement, this is the positive side of the cell, and this voltmeter is connected parallel to the cell. And from a negative, we have a coming wire coming, then we have an ammeter, then this wire, then this resistor, and then we have this switch, and this is connected with the positive side of the battery. So let me show you, I made that. So this is the circuit symbol, the circuit diagrams. Here you can see, here is that positive side of the battery, negative side. Parallel to the battery, we have a voltmeter. Here we have a switch, then we have a resistor, then we have an ammeter, and then the wire comes back to the negative side of the terminal of the battery. So this is what you have to do. Okay, so we are now going to the next question. The student records the current I and the potential difference V across the resistor X when the switch is closed. He calculates the resistance Rx of the resistor X. He replaces the resistor X with the resistor Y and repeats the experiment. The values are recorded for both resistors are shown in the table 2.1. So this is the table 2.1. So here I know when the resistor X was connected, the current was 0.1 ampere and the voltage was 1 volt. So the resistance will be, the resistance is, remember that formula V by I. So divide 1 with 0.1, you get 10 ohm. So the answer is 10 ohm. Now for the Y, the voltage is 1 volt and the current is 0.07 ampere. So I will divide the voltage with the current. So I will get the resistance. Let me show you. So let me show you. Okay, so you can see here, R is equals to V by I. So R will be equals to I divided by 0.07. So it will be 14.28. It is 14 ohm. So the resistance will be how much? 14.28 ohm. So I will write here 14 ohm. He says this is a 2 marks question. Calculate the resistance Ry of the resistor Y and complete the table 2.1. Use the equation resistance is equals to V by I. Give your answer to the nearest whole number. So it's 14 ohm. 14 ohm is the right answer. 14.28. So 14 ohm is the right answer. Final answer will be 14 ohm. Okay. So the next question is. He says the student combines resistor X and Y in a parallel arrangement. He uses this combination in the circuit in the figure 2.1 in place of the single resistor Y. The figure 2.2 shows the ammeter reading for the parallel arrangement. So the current coming from the battery is how much? We have to record the reading of the current shown in the figure 2.2. So we have to note down how much is this reading. So let me increase the size so you can. So this is 0, this is 0.1, this is 0.2, 0.3, 0.4. So this is, it has crossed 0.1. So 0.12, 0.14, 0.16. So the reading right now is 0.16. The reading is 0.16. So we will write here 0.16. The reading is 0.16 ampere. Okay. Now, then he says the potential difference stays at 1 volt using the values of I in the B first part and the Qn in the B second part. Calculate the resistance RC of the parallel combination. You see the resistance of the combination will be equals to the voltage of the battery divided by the current coming from the battery, and we know the current coming from the battery and we know the resistance, sorry, we know the EMF of the battery, so very easily I can calculate. So you see here we go, it says the resistance of the combination will be V by I, the voltage is 1 and the current is 0.16, so it will be 6.25. So the resistance is 6.25 ohm. 6.25 ohm, so it will be 6.2 or 6.25. So our answer is right. Okay, so the next thing they say, the theory suggests that the resistance RC of the two resistors X and Y arranged in parallel is given by this formula. RC is equal to RX RY divided by RX plus RY. State giving a reason whether your value for the RC in the B third part agrees with this suggestion. Okay, in the B third part, the RC value is 6.25 ohm. So if I will put the values here, Rx is 10, Ry is 14. So 10 plus 14 in the denominator. So you will have 140 divided by 24. So that's 5.8. The RC value through the experiment is 6.25. And by the theory, the value is 5.83. So if you check what is the difference between them, that is 0.416. If you convert that into a percentage difference, so that will 0.416 divided by 6.25 multiply 100, and that will be 6.4%. So the difference between the real value, the practical value, and the theoretical value is 6.4%. So 6.4% of the practical value. So yeah, if the difference is up to 10%, it's negligible. Not negligible, I mean it's acceptable. That difference is acceptable. So this is within the limit of that acceptable limit. So this is only 6.4% difference. So we will say yes, both are within the experimental accuracy. Okay. So that is how you will do the question number 2. It's C part. I hope you understand. And the next one is the next question. He says, so here we have. He says that a student directs two parallel rays of light, say ray 1 and ray 2, towards the side of a transparent plastic block, as shown in the figure 3.1. The block rests on a sheet of paper. So this is ray 1, this is ray 2, and this is that plastic block. You can say it's like a lens. Okay. So then they say the student marks 2 points, R1, and the student marks 2 point R and S on the path of the ray 1 after it has passed through the block. On the figure 3.1, draw a line joining S and R and continue the line to meet the block. So you will, with the help of the scale, join S and R until you meet the block. Okay, so join with the scale up this S and R until you touch the block. Then it says on the figure 3.1, draw a line to complete the path of the ray 1 through the block. So you will join this point and that point where this ray has touched each other. So let me show you from here. So you can see here I have drawn that. So join S and R until the block and then continue this R up to here. Then he says the student marks, okay, join this point and this point with each other with this line. Okay, you can see this line. Then he says the student marks the 2 points W and X on the path of the W and X on the path of the ray 2 after it has passed through the block. On the figure 3.1, complete the path of the ray 2. Okay. So what I will do, X and W will be completed and ray 2 will be here, touch here. So I will join these two with each other, this line. Okay. Then they say, okay, extend the line SR and the XW back until they meet at a point. Label this point F. Okay. So what you will do, you will continue this S and R straight, and X and W also join them and go straight. So where they cross each other, we will call that point, we will label that point as F. So you can see they have crossed each other. If I prolong them and I prolong them, so they cross each other here at point F. Okay. So then he says, measure the perpendicular distance from F to the center of the block. So with the help of the scale, measure the distance of the F from this point, from this dotted line, perpendicular distance. So that distance will be, when you do it with the scale, it will be 2.3 centimeter. It will be 2.3 centimeter. So I can show you the marking scheme also, 2.2 plus minus 0.1 centimeter. So that's the answer. Okay. Then he says, we are done with this. He says, so this is over. Okay, now we are going to the next question. The next question is question number 3 is done. Okay, so we are going to the next question. The next question is question number 4. I can show you once again this. Okay, question number 4, he says, a student determines the diameter of a thin wire. The apparatus available is 2-meter length of the wire, thin wire cutters, rulers. Suggest how the student determines an accurate value for the diameter of the wire using only the apparatus listed. Draw a diagram to illustrate your method. It's the 3 marks question. So, okay, let me show you my solution. So, here I have drawn this diagram. In this diagram, what we do, we take the wire and we wind it on the rule in such a way that all the coils touch each other. And for example, there are 10 turns here. You measure how much is the distance from A to B, in which you have those 10 turns. And whatever is the distance AB, you divide it with the 10, you get the diameter of the wire. This is one method. The other method is this. You cut with the help of the wire cutter, you cut 10 centimeter long pieces of that wire, and you place 10 pieces side by side, such a way they are touching each other as shown in the diagram, and you put a scale with them as shown in the diagram. Then you check the distance from this point A to point B. So whatever is this length, divide that length with the 10, because you have put 10 wires here side by side. So that will give you the diameter of the one wire. So that is how you write it. I have written the answer according to this, and there are two methods. You can write whatever you like. You can write about this method. You can also write about this method. I have written about this method. So cut 5 centimeter long pieces of wire with cutter, put them side by side, 10 pieces, put a scale along them as shown in the figure. Check AB distance, divide this distance with the 10 to get the diameter of the wire. So this is our answer. So here is the line up horizontally diagram, measure across 5, more diameter and divide by 5. Okay, we have put 10 wires. Okay, the last question they are asking is, a second student determines the diameter using a different piece of apparatus. His value for the diameter is more accurate. State the name of the different piece of apparatus he uses. You see, if you want to measure the diameter of a wire very accurately, the instrument which we use is micrometer. So you can use micrometer. So this is the answer which I have written, micrometer. So this is micrometer. Digital calipers you can be also can be used. So my dear students, this paper is completed. So this was the paper. I think so it's over. Yeah, it's finished. So my dear students, today we have done May-June 2022 4-1 paper. And this is paper 4, alternative to practical. I have tried my best to explain you how to write the answers. I hope you have understood the procedures and the answers. And if you have found this video useful to you, if this has helped you to solve this paper, and you think that this can help other students also, please share the link of this video onto your Facebook account, onto your Twitter accounts, and onto your Instagram. And this will help me promote my channel definitely. So thank you very much, everyone, for being patient and watching this video. It's a great blessing for me that I can make these videos. And thank you very much. Have a good day. God bless you all.